So yeah, as you can see, the title of my talk is React Native Pitfalls, not even once. It's basically, it's quite a bold statement, if I must say so myself, but I believe that if you have a good grip on the actual asynchronous nature of React Native, React and JavaScript, then writing React Native applications should be a breeze, pretty much. But before I jump into the talk, I just want to preface this quickly. The talk is going to be slightly advanced, but I am going to include some basics for accessibility, pretty much. So what exactly is React Native? Now, React itself, as some I know, it is essentially just basically a JavaScript library that is used to create user interfaces, as well as to componentize them correctly, pretty much. Now, React Native is more of a framework in the sense that it also utilizes this very same React library, but what it does is it combines the best worlds, the best two parts of like web development and native development, and essentially just bridges them over. So it allows you to essentially just take your web development skills and create native mobile applications. So with that said, how exactly does React work? So I believe, in my personal opinion, a good place to start is React components. What React components are is basically, it's simply just a class. And then within this class, you might have state defined, that's usually the case. And then also you'll have certain lifecycle methods defined as well, like component update, component mount, as well as the render method. Now, out of all of these specific methods, the render method is by far the most important. This is because basically React depends on the render method to essentially just generate a declarative object, pretty much, that's going to be used to actually retrieve the actual what's the word I'm looking for? The implementation of the component, pretty much. So the way that is done normally is we write it using JSX, which is what you can see in the return of the actual render method down there. Now, normally, obviously, this is not going to run. So even if you try and execute this, it's just on the browser. Obviously, it's really not gonna work. So what happens is that React basically transforms your JSX into a bunch of React.create element calls, pretty much. So this is actually not something that you want to work in or dev in. This can get really convoluted and difficult to follow, and so on and so on and so on. So that's basically the reason why JSX is used. Now, a thing that you need to keep in mind here is that React Native, or these specific create element calls, will just simply return an object that represents the actual element that's going to be used on the platform. So in the case of the browser, it's eventually going to become your h1 tags, your div tags, and paragraph, and so on. But in terms of React Native, it's what's going to happen is they'll eventually map to your native UI components that the actual device uses to actually generate stuff and so on. So another thing that's very, very important to keep in mind when it comes to the actual React components is that those specific components, those classes, they're subject to the essential 3 lifecycle phases of React, pretty much. So you might have mounting and updating and unmounting, but that it's quite important to have that framed in terms of the 2 phases in React itself. So, for instance, a component, what it means is that if a component has not been inserted into the DOM, it's essentially going to be what's the word I'm looking for? It's referred to as unmounted. So on the very first render cycle that React's going to go through, it's going to take all of your components and it's essentially going to try and mount them for the first time. So what mounting would do, what React's going to do is it's going to call the constructor of that specific component first. And then right after that, it's going to call render, that specific method I was showing earlier. Now, that render method would actually generate a subtree, hence the stuff being nested. And React would use that specific subtree. It's going to call the render methods of all of the components throughout your application, and it's going to generate a virtual DOM. Now, this specific virtual DOM is basically what it's going to use and compare against the real DOM to figure out what eventually to update. So after the render method has been called, it's basically just going to do what I said just now, and it's going to create an update list. And as soon as it has this update list, it would actually just insert those specific components or nodes into the DOM. And once that is done, it's going to call component did mount. Now, one very important thing that you need to keep in mind here is that component did mount, and I used to make the same mistake when I was starting out with React. I used to think that component did mount fires after the actual component has been painted on the browser, which is not the case. So as soon as the actual DOM node has been inserted, it would call component did mount for that specific component. And then after that, it's going to hand over control to the actual browser to complete the layouting and also to paint stuff on the screen. Now, it might seem, trivial or not really important, but it's quite an important fact to remember once you start developing applications in React. So after your component has been mounted and that specific component receives new props, or you change your internal component state using set state, what's going to happen is React's going to pick that up, and instead of just re-rendering that component itself, it's eventually going to re-render the entire virtual DOM again, just because it picked that up. This is done so that it knows and it can easily, it can just compare the virtual DOM to the DOM, and it's not really a problem. Otherwise, it has a lot to do with, it has a lot more, it's going to be difficult to compare and optimize and so on. So it's going to create an entire virtual DOM during render, and it's just going to compare. And after that component has been updated, it's going to call component did update. This is because the component's already been mounted. There's no need to call component did mount again. And the final lifecycle phase, as you can see, is unmounting. This is essentially once the virtual DOM has been generated and you have your normal DOM, and you can actually see that, or React just picks up that the DOM node should disappear. It's basically gonna, right before it removes the DOM node, it's gonna basically just call component will unmount. Now, this is fine and dandy, but one thing that you also need to keep in mind during React's commit phase that you can see on the left-hand side is that this commitment or this updating of the DOM, especially in terms of React Native, this happens asynchronously over something that's called the bridge. Now, there's a lot of details and stuff that I can get into here, and this is quite simplified. But for the most part, it's fine if you just keep and if you just frame it like this. Essentially, just two threads basically running, and then also the communication between them happening over a bridge. So what's going to happen here is as soon as you do, as soon as the actual commitment needs to be done by React, a bunch of instructions are basically going to be generated in terms of basically just an object that's going to get serialized. And then as soon as that object's been serialized into JSON, that's going to get sent over to the bridge, and the UI thread will just pick that up, and it's going to see, okay, well, I need to create this, this, and this, and it's essentially just going to create that. So before I move on to the demonstration, right, there's a specific pitfall that I want to get into. But before I get there, I just want to explain quickly how the event loop basically works. Now, that's quite a large topic on its own. It's quite rough, but I'm going to try and keep this short, just in terms of the set timeout, essentially. So this is essentially just a depiction that was done by Robert Phillips, I believe, during the 2018 JavaScript conference. And all this is actually showing is essentially the elements or the parts that you need to keep in mind of when trying to understand the event loop. So what's going to happen is, as soon as your JavaScript gets executed and it gets to a set timeout, the set timeout, we just take a callback and essentially kick off a timer. And then once that specific timer is done, it's going to essentially just push that callback on the task queue, right? So this is called the callback queue, but the task queue is a more fitting name in terms of set timeout. There's all kinds of details here, so I'm just going to call it the task queue for now. And then as soon as that callback or that task gets to the front, and the call stack is empty, the event loop will just simply take that callback, push it onto the call stack, and execute that. Now, JavaScript, as you know, is a single-threaded language, so it can't really do stuff in parallel and so on. But what it can do is defer code to a later point for execution, and that's essentially what's going to happen if you use a set timeout with the timer and a callback and so on. Okay, so with that out of the way, time to demo. So this is a very involved user interface, as you can see. And this is literally just to depict the actual problem itself. So I just have a bunch of items here that's getting generated just from some mock data. And then I have a button that also just produces stuff. So what exactly do I want to achieve here? What's the point? So what I want to do is, on this open right here, I just want to generate the other components for displaying, and then simply scroll to the bottom. Okay. Now, normally it sounds like a trivial thing. It's not really a problem, but you'd be surprised that it can sometimes get quite a little tricky to do stuff like that. So we're just going to open this quickly. That's fine. So I just want to keep it like this for the explanation of the two components quickly. So if I can jump to the code, the actual this actual component that's declared over here, this is simply this first part with the bunch of items. And then it actually has a child component called dropdown. You'll see that I actually declaratively stated in the JSX down here. And this specific dropdown is basically the button is in there as well with changing states and so on, and also just displaying stuff. So that's basically what that is. So now that we understand the user interface and our stuff is a little bit structured, the way that you want to solve this normally, if you just think about it really quickly, is that you want to use the lifecycle hooks that React just provides, like component mount, component update. And as you can see, I've declared this in the parent component. I've done the same thing in the child component. Now, they're empty, and they're empty for a very good reason. It's because, as I mentioned earlier, you won't be able to scroll because the two threads operate kind of their own. You won't really be able to scroll on an on press. So if I actually try, and let's just enable that quickly. If I actually try and scroll directly on the on press, this would fail. Now, this just simply tells the scroll view to scroll to the bottom. Okay, so hopefully that should be fine. It shouldn't break. Okay, that's cool. So if I click it now, what's going to happen? It's just not gonna scroll. So, and this is where the specific pitfall comes in, and I've seen this recommended on Stack Overflow and a few other tutorials and stuff like this. And I've done this myself. Especially when I started out. I've also committed the same sacrilege. So what's going to happen here is that that same method to tell the scroll wheel to scroll down is going to get passed to a set timeout. And essentially what's going to happen is after the 100 milliseconds has passed, it's just going to fire this off roundabout, not exactly because of the event loop. And essentially everything should be fine and it should scroll, okay? So if I go back and stuff that refresh, that should be fine. Same thing, scrolls, works, okay? So that's not really what you want to do. The reason why the set timeout works is because after the 100 milliseconds has passed, it's going to call the scroll function. Now, that's just enough time to allow the UI thread to essentially calculate the layout and generate everything after it's been passed over the bridge. Now, people would just do this and they would essentially just call it a day and, you know, we're done, boys, going home. And they'll be happy with that. And that's not really a good solution at all. So this is very, very, very performance specific, right? If you have a device that is rendering the UI too slowly for this specific set timeout, it's just not going to work. So even if you fine-tune this to, like, let's say, I don't know, 50 milliseconds or whatever, you test it in the emulator, it works, you can just, you know, stuff's fine. What's going to happen is as soon as the device gets really busy with whatever else and there's not enough resources to generate the user interface quickly enough, you're going to run into the problem of trying to scroll and the layout hasn't been calculated. And it's just going to sit there and it's going to be a real problem. So that's really, really not good. So there's an actual risk of stuff failing and it's really not optimized as well. So that's one of the pitfalls that I actually fell into quite a lot. Well, not quite a lot. I used to like just do the same thing and just like be happy with it. It's really not good. So the way that this should be solved is what this is doing, I'm just telling the parent component that, okay, yeah, you can scroll because I clicked the button. But the way that this should be solved is that you want to literally on content size change, which is just this property right there, pass it a callback. And then if the button has been pressed, so this dot should scroll is true, you want to just scroll to the end. Now, what on content size change does is that it uses on layout underneath, which is provided by React Native. Now, on layout pretty much does basically what the name suggests. It just fires off a callback function once the actual layout changes. Now, that happens right before painting, but that is perfectly fine because we know what the layout is already. Okay, so the browser or the device would know how far down to scroll to. So it's not really a problem. So if I can do the same thing, open here, and it works perfectly the same result as the set timeout, except that it's not really performance. It's not really reliant on the performance of the device. So that basically works, and I'm quite happy with that. Now, a thing that you just need to keep in mind is that Facebook knows about the specific problem surrounding the asynchronous nature of the bridge. And they've basically embarked on a journey a few years back to fix it. They're essentially re-architecting a lot of the React Native platform pretty much. And a lot of the things that they were intended to implement has already been implemented. And they were planning originally to decommission the bridge around about this time this year. And that hasn't happened yet. So you still have to keep in mind that the bridge is kind of still around as you're developing applications. And yeah, I think that's pretty much it.